Welcome to the DIY Honda Garage channel. DTC P0339 refers to an issue where the crankshaft position sensor circuit experiences intermittent interruptions. This sensor plays a crucial role in engine management by detecting the timing of fuel injection and ignition for each cylinder, as well as monitoring the engine's speed. Specifically, the crankshaft position sensor, or CKP sensor, is integral to the operation of the powertrain control module, PCM. Located typically near the crankshaft pulley, the CKP sensor uses a rotor and semiconductor to generate pulsing signals that signal the PCM regarding the engine's operating conditions. If the PCM detects abnormal signals, indicating an issue with the CKP sensor, it will store this diagnostic trouble code, DTC, in its memory. The ability of the CKP sensor to relay accurate information is essential for the engine's optimal performance, making this DTC crucial for diagnosis and repair. Preventive maintenance is vital in forestalling issues such as DTC P0339. Regularly inspecting the CKP sensor connections can help catch any potential problems before they escalate into significant failures. Pay close attention to the wiring for signs of wear or corrosion, as environmental factors can lead to deterioration over time. Implementing a routine diagnostic check can also assist in identifying lurking issues within the sensor circuit or PCM before they trigger a warning symbol. Proactive maintenance will ultimately assist drivers in ensuring the reliability and performance of their vehicles throughout their lifespan. Adopting these practices may help minimize the chances of engine performance disruptions linked to the CKP sensor. In conclusion, the CKP sensor is critical for the proper functioning of an engine, as it directly influences fuel injection and ignition timing. DTC P0339 indicates that there is an issue with the sensor circuit, leading to intermittent signals, potentially caused by electrical noise, sensor damage, or PCM failures. Careful and thorough diagnostic procedures are essential to correctly identify and address the problem. Following the troubleshooting steps outlined, including checking the CKP sensor and PCM functionality, can guide technicians in effectively resolving the issue. Establishing a routine of preventive maintenance helps in reducing the recurrence of such issues, ensuring engine integrity and performance are maintained. The error associated with DTC P0339 involves the crankshaft position sensor, which has a critical role in determining the timing for fuel injection and ignition in each engine cylinder. Located near the crankshaft, the CKP sensor consists of a rotor and a semiconductor that detects the rotor's position during engine operation. When the engine starts, the rotor spins, resulting in changes in the magnetic flux that is detected by the semiconductor. Essentially, these changes produce pulsing signals sent to the powertrain control module, PCM. If there are issues with the signals, such as receiving an abnormal number of pulses during crankshaft revolutions, the PCM will store this trouble code for further action. This sensor not only assists in engine performance, but is also vital for emission control, as it significantly impacts the combustion process. Several factors could lead to the triggering of DTC P0339. Firstly, electrical noise overlapping the CKP sensor circuit, specifically in the CRKN line, can interfere with the accurate transmission of signals to the PCM. This noise can result from various issues, including poor wiring connections or damaged insulation. Secondly, if the rotor within the CKP sensor is chipped or damaged, it can produce inaccurate signals that lead to misinterpretation by the PCM. Furthermore, a complete failure of the CKP sensor is another potential cause that would prevent it from sending any signals, thus triggering the DTC. Lastly, an internal circuit failure within the PCM itself can also generate this diagnostic code. indicating potential issues within the control module that need to be addressed. The symptoms associated with DTC P0339 may vary, but they notably include engine stalling, which can be alarming for drivers. This stalling occurs due to the CKP sensor's inability to provide accurate timing information to the PCM, resulting in improper fuel injection and ignition sequences. Additionally, drivers may experience rough engine performance characterized by misfires or uneven running, leading to a lack of smooth acceleration. The malfunction indicator lamp, MIL, will also illuminate, signaling to the driver that a fault has been detected in the engine management system. These symptoms not only affect the drivability of the vehicle, but also indicate an underlying issue that should be promptly diagnosed and repaired to prevent more extensive engine problems. The first step in troubleshooting DTC P0339 involves checking the connections of the CKP sensor. It's essential to start by inspecting the wiring harness linked to the sensor for any signs of water damage that could lead to electrical shorts or poor connections. A moist environment can lead to corrosion, which can impede the proper functioning of the sensor. Properly seated connections are critical. Loose or corroded terminals can lead to intermittent signals that would trigger this DTC. Utilize a multimeter to test for continuity and proper voltage levels at the connector, ensuring that all pins are intact and secure. Only after confirming these connections remain in good condition should you proceed to further checks. For troubleshooting steps that follow, inspecting the CKP sensor rotor is crucial. Begin by visually examining it for any chips, cracks, or physical damage that could affect its ability to function correctly. A damaged rotor will not produce the necessary magnetic changes, which are essential for signal generation. You should also check the alignment of the sensor and ensure that the air gap between the rotor and the CKP sensor is within the specifications outlined in the service manual. An incorrect air gap can significantly diminish sensor performance, producing unreliable signals that lead back to the triggering of DTC P0339. Utilizing calibration tools may be necessary to ensure everything is set correctly for optimal functionality. The next important step is to test the functionality of the CKP sensor itself. Use a scan tool to see if the sensor is providing valid signals to the PCM during engine cranking. Monitor the parameters associated with the CKP sensor to ensure it outputs an acceptable number of pulses that correlate with the engine speed. Confirming proper voltage output to the sensor is vital, as inadequate power supply can result in malfunction or erratic behavior. If the readings are irregular or do not match the expected values, the CKP sensor may need replacement. Make sure to compare specific readings with the manufacturer's specifications to determine whether the sensor is performing as intended. Finally, examine the powertrain control module for any operational failures. Confirm that the PCM is processing signals correctly and there are no internal faults that could affect its communication with the CKP sensor. Utilize diagnostic equipment to run specific tests on the PCM to confirm its integrity. If necessary, resetting the PCM can sometimes aid in clearing transient errors and allowing it to relearn the sensor's behavior over time. After resetting, observe the system and recheck if DTC P0339 reappears, helping to indicate whether further issues persist or if the previous problems have been resolved. This step ensures that any internal faults have been addressed. After completing the troubleshooting process and making necessary repairs, the next step is final verification. Begin by clearing all diagnostic trouble codes, DTCs, from the powertrain control module using a scan tool. Following this, conduct a test drive under various driving conditions to ensure that the vehicle operates smoothly without any interruptions. Monitor the system closely for any reoccurrence of the DTC and check if the mal illuminates again. Successful verification further confirms the efficacy of the repairs made and assures the driver that the vehicle is ready for normal operation. This step not only checks the effectiveness of the repair, but also affirms the overall system's integrity. Please like and subscribe to the channel. See you next time.